Good evening to one and all. Just now I have started this session. So till previous class, what we have discussed, that is about Vivers, right? Vivers construction and all we have seen by direct inspection method as well as by singular transformation method. By two methods we have discussed about the Vivers construction. One is direct inspection method, singular transformation method. Yeah, fine. So please kindly confirm audio, video on screen once. Please kindly confirm the audio, video on screen once. Good. Is it okay? Yeah, good. Yeah, fine. See, next thing. So we are going to discuss about the bus impedance matrix. Sorry for the delay. Yeah. So let's start with the JetBus construction, bus impedance matrix construction, right? So I'm writing here bus impedance matrix construction. See, basically we have two techniques of this JetBus construction. Two methods we have for the JetBus construction. First one we can say that is inversion of the Y-bus. Simply you construct the Y-bus for a given power system network or given network, whatever it is. You do inverse of that, that will give the JetBus matrix. That is one of the easiest technique, right? So first one we can say methods to construction. First one, inverting Y-bus matrix. Inverting Y-bus matrix, right? So I can write JetBus is nothing but inverse of the Y-bus, provided that your network remains as it is. Provided that your network remains as it is. For what network you want to find out the JetBus, right? Take up that network, find out the Y-bus of that, and you take the inverse of that, that will give the JetBus, right? Second method. See, actually in olden days, maybe in the times of 1930s, 1940s and all, we don't have that sophisticated computer technology to find out the inverse of the matrix. Particularly, if you think a 100-bus system, we have a Y-bus size of 100 by 100. Inverting that 100 by 100 size of matrix is a bit laborious even by using computer. That's what the difficulty what the people have been facing. At that time, they proposed one method called as JetBus building algorithm. JetBus building algorithm. By using that, it is possible to find out the JetBus matrix, right? But nowadays, we are having good technology with MATLAB or Python programming or something. So we can find out the inverse of the Y-bus easily with a one click in the computer. Okay, in present days, the people are going with this one only, inversion of the Y-bus. But in olden days, we have a method called as JetBus building algorithm. JetBus building algorithm. JetBus building algorithm. But anyway, we are not going to discuss in detail about any one of these two, inverting Y-bus as well as JetBus building algorithm. See, actually in our syllabus, we don't find a term called as JetBus at all. We don't find a term called as JetBus, particularly in case of GATE I am talking. In case of ESE, we have a topic called as JetBus building bus impedance matrix, right? We'll discuss with respect to that, how to construct the JetBus in the easiest way, maybe by using network analysis technique, how to construct the JetBus. That I will discuss one or two problems. Okay. And then our main concentration will be here, how to do fault analysis with the help of the JetBus matrix. How to do fault analysis with the help of JetBus matrix. Okay. Before moving ahead, before discussing anything further, initially I am taking some small example here. I'm taking some example. Kindly observe this example. A power system network is having a Y-bus matrix, something like this. Just look here, this Y-bus. Minus J10, J6, J4, J6, J4, minus J20, and you have J14, minus J18. So this is Y-bus matrix of a power system network of 3-bus. This is the Y-bus matrix of a 3-bus power system network. Could you please find out the JetBus of this one by taking inverse? Could you please find out JetBus by taking inverse of the Y-bus? Tell me please. JetBus is equals to Y-bus inverse. Na? So take up the same matrix and find out inverse. You can take that J out. And you can write here J inverse first. And then multiply 2 minus 10, 6, 4, 6, minus 20, 14, 4, 14, minus 18, inverse. Okay, J inverse, and you have this one minus 10, 6, 4, 6, minus 20, 14, 4, 14, minus 18. Yeah, you try to find out inverse of this one. Try to find out inverse of this 3 by 3 matrix only, right? 3 by 3 matrix, and by in calculator with one click you can get that inverse after feeding the matrix. If you Take that inverse, you will get it. Tell me, anybody? Anybody? I think you don't get this inverse in the calculator. It will say simply math error. It will say simply math error. Math error in the sense, we will say it is undefined. Undefined means these values looks to be infinite. These values looks to be infinite. Moreover, you can say in another word, inverse of that Y bus matrix does not exist. As the inverse of the Y bus matrix does not exist, I can say Z bus can't be constructed. It is not possible to construct the Z bus in this particular situation, right? That does not mean that Y bus inverse was failed to construct the Z bus matrix. We should not say this statement. Kindly observe my words. Kindly observe my words. We should not say that inverse of Y bus is not giving Z bus. That's not the statement. In this particular network, what we are discussing, right? We can't find out the Z bus matrix. That's the statement you have to write. Yeah, I'll write the next slide. So in this case, Z bus matrix can't be constructed. Can't be constructed. Can't be constructed, or it is not possible to construct the Z bus matrix. It is not possible. Not possible to construct. Possible to construct the Z bus matrix. Z bus matrix. Right? So it is not possible to construct the Z bus matrix, you can see. Okay, fine. Next thing. Kindly listen to me. What is the property of this matrix? This we have to discuss now. For example, if you see, what is summation of first row in your Y bus? What is the summation of first row in your Y bus? 0. What is summation of second row in your Y bus? Also 0. What is the summation of third row in the Y bus? That is also 0. Yes or no? First row summation is 0, second row summation is 0, third row summation is also 0. What's the meaning of that? What's the meaning of that? Yeah, I need your response. Please tell me. What's the meaning of that? First row summation 0, second row summation 0, third row summation also 0. I don't have any shunt element at the bus 1, bus 2, as well as at the bus 3. Means I can say simply, if you don't have any shunt elements in the system, it is not possible to construct the Z bus matrix. Okay, or else I will say in a different way. To have a possibility of Z bus construction, at least one shunt element should exist in the system at any bus. At least one shunt element should exist in the system. That's the condition we have to consider now. Okay, let me show in the next slide. So it is not possible to construct the Z bus matrix you have written, and I will say here, because no shunt element exists in the system. No shunt elements exist in the system. No shunt elements exist in the system. Okay, yeah. So I'm writing that other statement what I said, right? Z bus matrix can be constructed if and only if at least one shunt element exist at any one bus. Any bus is having at least one shunt element. That is sufficient to say that the Z bus can be constructed. See, actually, this statement is valid for both inverting technique as well as for the Z bus building algorithm. In any one of the case, this statement must be satisfied to have a possibility for the Z bus construction. Right? Fine. Next. So I'm asking one very simple question to you. Simple question. Tell me, if anybody asks you this question, you have a practical power system network. Is it possible to construct the Z bus or not? For a practical power system network, is it possible to construct the Z bus matrix or not? That's the question. Yes or no? Yes. Yes is the answer. Why? What is the reason? What's the reason? Definitely we have a shunt element by means of generator, right? You don't have a practical system without generator. You don't have a practical system without generator. So as and when you say we have a generator, definitely there exists a shunt element in the system and it is possible to construct the Z-bus matrix, definitely. Okay, next. Just see, actually the statement what I said now, it is not possible to construct the Z-bus if you don't have any shunt element. It's not a very new statement to you. This you might have studied even in network analysis also at some time. I'll show you. For example, I have a two-port network, something like this. I have a two-port network, something like this. This is a 1, 0, you write 2, 0. 0 is the reference of this. 0 is the reference and 1, 0 port 1, 2, 0 port 2. And this impedance I am showing as Z. Impedance I am showing as Z. And could you please tell me what will be the Z-bus matrix of this? What will be the Z-bus matrix of that? Anybody? Anybody please tell me what is Z-bus matrix of this network? Yeah. What will be the Z-bus matrix of this network? Can't be find. We can't find the Z-bus matrix of that. 1Z01 is a ABCD matrix, right? Sivagopi, 1Z01 is a ABCD matrix. For this, Z-bus matrix can't be constructed, right? For this network, Z parameters are, you write Z-bus matrix. Z-bus matrix can't be find, can't be constructed. What's the reason? Can't be constructed. What's the reason? Because we don't have any shunt elements in the system. We don't have any shunt elements in the system. Okay, done. But Y-bus can we construct for this? Anybody? Can we construct Y-bus for this one? Yeah, Y-bus, yes. Can you please tell me what is Y-bus for this one? Y-bus or Y parameters? Any name you can call for this. What will be the Y-bus matrix or Y parameters for this one? It's a bus 1, bus 2 you indicate. It's a bus 1, bus 2. It's the reference node, of course. Bus 1, bus 2. Okay. What is Y11? What is Y11? For example, you assume that this is having an admittance value Y equals to 1 by Z. Admittance value Y is equals to 1 by Z. To the node 1, how many admittances are connected? Only one admittance. That is Y. That Y itself is capital Y11. That Y itself is capital Y11. What is Y12? Capital Y12 is negative of the primitive admittance between bus 1 and bus 2. It is minus Y. Okay. What is Y21? Negative of the primitive admittance connected between bus 2 and bus 1. So it is minus Y. What is Y22? Only one branch is connected, Y. So that will be the Y parameter matrix of this one. Y parameter matrix of this one will be Y minus Y minus Y, Y. That is a Y-bus matrix or Y parameters. Write this one, else you can call this as Y parameters. Y parameter matrix. Yeah. So I think all of you getting this one. I think clear. So now let's take some simple problems in the construction of the Z-bus matrix. Yeah, go through this quickly. Find Z-bus matrix of the following resistive network. It's a question asked in previous ESC prelims examination. Previous ESC prelims examination. Go through this now. Find Z-bus matrix of the following resistive network. Resistive network. Yeah. Resistive network. Simple. We have two buses here or two nodes. You can say 1 and 2. What will be the size of Z-bus? 2 by 2 matrix. 2 by 2 matrix. Let me write first. Z-bus is of the size 2 by 2. Z-bus matrix will be of 2 by 2 size. So we have to find Z11, Z12, Z21, Z22. Okay? Yeah. Next thing. First, how to calculate Z11? Anybody? Tell me. Any other name for Z11? Any other name you have for Z11? Tell me please. Any other name we have for Z11? Z11 is nothing but Thevenin impedance with respect to bus 1. Z11 is nothing but Thevenin impedance with respect to bus 1. What is Z22? What is Z22? Thevenin impedance with respect to bus 2. So first you calculate Thevenin impedance with respect to bus 1. That will give Z11. Thevenin impedance with respect to bus 2. You will get Z22. After that, we think about the values of Z12 and Z21. Okay, else, if you want me to go with a procedure, I'll take first current injection at bus 1, and no current at bus 2. And I will find out V1, V2, and then I will find out the respective Z bus elements. Okay, better I will write in a procedure. Current injection at bus 1. Current injection at bus number 1. So I am keeping some current source at bus 1, something like this. It is I1. Okay. Now tell me please. You observe here. 2 will be in series, obviously, because I don't have any current at bus 2. 2 will be in series. Means it will be 4 in parallel with 1. 4 in parallel with 1. So this network you can redraw something like this. This is I1 current. And here it is 1 ohm. And this is 4 ohms. It will be in parallel, and you don't have node 2 here. We have removed that node 2. And this is your node number 1. And 1 in parallel with 5. How much is that equivalent value? 1 in parallel with 5 means 1 into 4 by 1 plus 4. It will be 4 by 5. 4 by 5. Then what's the value of V1 I can say? Bus 1 voltage. That is nothing but I1 into 4 by 5. Bus 1 voltage is I1 into 4 by 5. From that one, we can get Z11 number. Okay. Please complete it quickly. Please complete this one quickly. Very simple thing. Kindly follow it. So voltage V1, if you write, it will be coming like 4 by 5 times of I1. Means that number Z11 is nothing but voltage V1 by current I1, which will come 4 by 5 ohms. Z11 number is 4 by 5 ohms by keeping open circuited bus 2. Okay, next thing. Getting all of you? Next. So you try to find out this voltage V2. Try to find out that voltage V2 in terms of I1. V2 you try to find in terms of I1. For that purpose, you assume this current something like Ix. You assume that the current flow is Ix. By doing current division, you have to get it. By doing current division. What is the Ix you can write? By current division, Ix is equals to I1 into opposite impedance 1 by 1 plus 4. Okay? Yeah. By current division, current Ix equals to current Ix is equal to, it will be I1 into 1 by 1 plus 4. Okay, so it's 1 by 5 times of I1. I1 into 1 by 5. That is Ix current. And what's the value of V2? V2 is nothing but Ix into 2. Because this is the impedance 2 ohms and current flow is Ix here. So simply Ix into 2 is a voltage V2 we can say. So V2 is equals to 2 into Ix. Means you can get this one 2 by 5 times of I1. Means you can write the value Z21 here, which is V2 by I1 number. What is that V2 by I1 number? 2 by 5 ohms. V2 by I1 is equals to 2 by 5 ohms. Like this, we are capable to get Z11 number as well as Z21 number. Yeah, all of you understand this one? Please tell me. Right? Simple thing. Simple way of calculating Z bus elements. Next thing. Current injection at bus 2 you take. Let's move. Current injection at bus 2. The same problem we are continuing. injection at bus 2. You take the current simply as I2. Simple, like Z parameters calculation we are doing. Like Z parameters calculation. Yeah. So I will be keeping this current as I2 here. I2. Next thing. Observe. You find out this node voltage V2 and you find out this node voltage V1. And then you get V2 by I2, Z22. V1 by I2, Z12. Simple, right? See, you observe now, this 1 and 2 will be in series, so it will be 3. 3 in parallel with 2, that's the equivalent. Let me draw. It is 3 ohms in parallel with 2 ohms. 3 ohms in parallel with 2 ohms. So it is the current I2 we are talking now. I2, and this is a voltage V2, of course. And what's the parallel combination of these two numbers? 3 into 2 by 3 plus 2. So it will be 6 by 5. 6 by 5 ohms. 6 by 5 ohms. Now, the value of voltage V2 is nothing but 6 by 5 into I2. 6 by 5 into I2. So this implies Z22 equals to V2 by I2. This number is 6 by 5 ohms. That's the Thevenin impedance with respect to bus 2. This was a Thevenin impedance with respect to bus 2, we can see. Z22 number 6 by 5 ohms. Next one, Z21 we have to get, right? Z21. How much is the Z21 value expected? Z21 will be equals to Z12 only. Sorry, Z12 we have to calculate. Z12 number will be equals to Z21 value only. Z21 already we have done 2 by 5. Z12 also comes to be 2 by 5. That will prove. That will try to prove. Let us say this current is again some IY current. IY current. For that IY, you can say by current division, I2 into opposite impedance is 2. 2 by 2 plus 3, you can say, right? Current IY. Current IY is equals to I2 into what you can say? Opposite impedance is 2 ohms by 2 plus 3. So it will be 2 by 5 times of I2. IY is equals to 2 by 5 times of I2. Next thing. What is V1? V1 is nothing but 1 into IY. 1 is this resistance value 1 ohm into current is IY. So I can say V1 is equals to IY into 1. So simply IY. So it is 2 by 5 times of I2. And you can write Z12 number from this, which is V1 by I2 number. This is 2 by 5 ohms. That's what I said earlier. Earlier we got Z21 number 2 by 5. Z12 also comes to be 2 by 5 ohms. 2 by 5 ohms. Clear? Now you can write that Z-bus matrix. Z-bus matrix, very simple. Z11, it is 4 by 5. Z11 is 4 by 5. Z12, Z21, Z22 number, it is 6 by 5. In terms of ohms, you can see. In terms of ohms. Fine. So this is one of the easiest technique to find out the Z-bus matrix in the TSC prelims examination objective questions. Any network given, definitely have the options, right? Option A, B, C, D we have. First to try to find out Thevenin impedances, right? Match the Thevenin impedances with the diagonal elements. Is it matching or not? That you check. And if it's matching in any two options, try to go with the calculation of transfer impedances, at least one row or one column. By that you can get these options, right? You can find out the correct option what it is. I'm showing previous slide. If anybody is still writing, please complete it quickly. Yeah. How many buses means maximum 3 they may give. If they are asking about the Z-bus construction, they may give maximum 3 buses. Maximum 3 buses. Okay, done. Next thing. Next, one more question I am taking up in the Z-bus construction only. See this one. It's also a very simple question. Find Z-bus matrix of the following network. Find Z-bus matrix of the following network. Right. So he said it is 1201 per unit, 3202 per unit, 32223 per unit. He didn't give these values clearly. He didn't give these values clearly. So assume that these are impedances only, right? These are nothing but impedances only, or else you consider these things as resistors, and yet you try to draw the network of this 3-bus system, and you try to find out the Z11, Z22, Z33, and then remaining elements, whatever it is necessary. Okay, yeah. So let's move ahead. So in the solution, I will be redrawing that network. 1 per unit between 1 and 0. 1 per unit between 1 and 0. Right. And this is 3, bus 3. 320, how much you have? 2 per unit. 322, how much you have? 322, how much you have? That will be 3 per unit. These are the per unit numbers of impedances. 1, 2, 3. 1, 2, 3 per unit impedances. Right. Next thing. You go with the current injection technique, what we said earlier, else calculate Thevenin impedances with respect to 1, 2, 3, and then transfer impedances. That's your wish. Let's say current injection at bus number 1. Current injection at bus 1. Injection at bus number 1. Current injection at bus number 1. Let me copy this network. Once, right? So I will keep that current source at bus 1, something like this, simply. This is the current source I am showing as I1. By giving that current, to find out the voltages V1, V2, V3, V1, V2, V3 voltage we find, and then V1 by I1, V2 by I1, V3 by I1, you will get the elements. Okay, what is the value of V1 now? What's the value of V1? Simply I1 into 1. So it will be I1 only, right? V1 is nothing but I1 into 1. It will be I1. But you know, there is no current flow in this branch. We don't have any current flow in this branch. So obviously V2 will be 0 voltage. V3 voltage will be 0 because it is connected to reference, right? It's connected to reference. So V2 equals 0 and V3 also equals to 0. Now, you're right. V1 by I1, that is nothing but 1. V1 by I1. V1 by I1, that is nothing but 1 per unit. Z11 is nothing but V1 by I1, which is 1. What is Z12? Sorry, Z21. V2 by I1 number, and the value V2 is how much? 0, so it will be 0. What is Z31? V3 by I1 number, that will be also 0. V3 by I1 number, that will be also 0. Like this, you will have Z11 is 1, Z21 is 0, Z31 also equals to 0. Okay, next thing. Current injection at bus number 2. Make it quick, please. Simple things only. But in the examination, you no need to do all calculations. I said you no need to do all the calculations. Simply you do one row or one column. Based on that, you can decide which is the correct option from the 4 options given. Current injection at node 2 or bus 2. Current injection at node 2. Or you can say at bus 2. So let me keep that network now. This is your diagram. And you keep this current source at the bus 2, something like I2 here. Keep this current source as I2. And you see this branch, whatever you have, is not carrying any current. So obviously V1 value will be 0. Not carrying any current means this node voltage is 0. So obviously this node voltage will be equals to reference voltage, that will be 0. Okay. Now tell me, what is V2 value? node 2 voltage. You observe this I2 is flowing in this complete branch and circulating back now. I2 is flowing in this complete branch and circulating. And obviously 3 and 2 will be in series. 3 and 2 will be in series. 5. 5 into the current I2 is a total voltage across these two impedances. That is nothing but the value V2 you can say. So it will be 5 into I2. Voltage V2 is nothing but 5 into I2. And what is the value of V3? What's the value of V3? See, this is the voltage what we need, V3. That is nothing but this resistor voltage only. What is the resistor voltage? 2 into that current. 2 into that current. So it is 2 into I2. 2 into I2. Now tell me, what is the value Z2, 1, 2, Z12, which is V1 by I2. V1 by I2, 0, because V1 value was 0. What is Z22? V2 by I2. What is V2 by I2 number? 5 per unit. What is Z23? Sorry, Z32. 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 So it is V3 by I2. What is V3 by I2 number? 2 per unit. 2 per unit. Clear. Now, after getting these numbers, let's take current injection at bus 3, last one, and we'll conclude the things. We will be concluding the things. Yeah, please complete it quickly. Please complete it quickly. Sir, V2 with respect to reference node only. Say always Dinesh, if I am asking you to measure one particular node voltage, will you measure with respect to other node or with respect to reference? It will be with respect to reference only, always. Any node voltage I say, that will be with respect to reference only. Sir, for ZBus, that rule 1, rule 2 method not needed. Vishnu, I am saying you we have many methods to calculate the ZBus. One method is inversing Y-bus. Next one we said what we call ZBus building algorithm. Another method is according to our flexibility, Z parameters calculation, current injections, finding out the voltages, current ratios. Whichever the method you are flexible, that you can follow. Okay. So ultimately, whichever the method you follow, you have to get the answer. Yeah, let's take current injection at bus 3 or node 3, you can say. Current injection at node number 3. Node number 3. Let me copy this diagram. This one. You have to keep current at node 3. Kindly observe this one. This is I3 current now. And you observe now, this I3 current is injected here. And it will attempt to flow in this direction with 3 per unit, but you have open. So this will carry 0 current now. The 3 per unit will carry 0 current. I3, whatever you have, it will circulate in the loop. I3, whatever you have, that will circulate in this loop. And you know, this branch is not going to carry any current. This branch is not going to carry any current. So obviously V1 voltage will be 0 because one is connected to reference. One is connected to reference through 1 per unit. And this is not carrying any current. This voltage is 0. So obviously bus 1 voltage also 0. Bus 1 voltage also 0. Kindly observe my words. Kindly observe. What is V3? What is bus 3 voltage now? Bus 3 voltage is nothing but I3 into 2. Bus 3 voltage is nothing but I3 into 2. I3 into 2. Okay, next thing. What is bus 2 voltage? Can anybody tell me? What is bus 2 voltage? Anybody? It's a basic network analysis principle only. Yeah, that will be nothing but the value of V3 because it is not carrying any current. So this node voltage, both will be equal. V2 and V3 are equal, which is nothing but 2 into I3. 2 into I3. Now you find out. I'll say Z13 first. Z13. So it is V1 by I3. Voltage V1, current I3. 0. 0 by I3 na? 0. What is Z23? Which is nothing but V2 by I3. What is V2 by I3 number? 2. What is Z33? Which is V3 by I3. What is V3 by I3 number? That's also 2. V3 by I3 number also comes to be 2 per unit. So now you can write simply the ZBus matrix by taking up all these things. All are okay. Anybody not getting the class? Somebody is complaining this. Somebody is putting a complaint that some people are not getting the class. Please kindly respond in Telegram. Please kindly respond in the Telegram. Little lag. This internet is very perfect, what I feel. Somebody saying all is okay. Panjali, no lag. Class is okay, sir. No issues. It's working okay. Yeah. Okay, good. Some students are unable to join. Some students are unable to join. That's the issue. Somebody is saying. Okay. Yeah, fine. Let's continue. So now let me write that JetBus as a whole. Simple. So I'm showing here. JetBus is equals to. You have to take up the bus numbers in a proper order. 1, 2, 3 order only you should follow. 1, 2, 3 order. Is 1, 0, 0. I think you get 0, 0 here also. Z22 number is the value 5. And then Z23 number we calculated. That number is 2. And this is 2. And the Z33 number, if you take, that is 2. So this is a JetBus in per unit form for the network, whatever they have shown. So in this, by looking into the figure, we can easily construct network. But in case if we are unable to construct the network, then how? Sivagopi Raju, you have to construct the network only. Without constructing network, you need to accept their incoming request. I didn't get where I have to accept it. Okay, 1 minute, please. 1 minute, please. I'll come back. I will try to inform this problem to the management.
Hello, sir.
Hello.
Hi, sir.
Tell me.
Yes, sir. Issue naimana?
కొంతమంది జాయిన్ కాలేకున్నారంట స్టూడెంట్స్.
అవునా, లేదు సార్, నేను కూడా ఉన్నా ఒకసారి. సో అయితే ఓ పని చేస్తాను. సో న్యూ సెషన్ క్రియేట్ చేస్తాను. సో అందులో జాయిన్ అవ్వమని చెప్తాను. ఓకేనా సార్? ఇది ఎండ్ చేయండి సెషన్. I will create one new session. Then after they will go for new session.
Yeah, dear students, the people will create a new session for you. You join in that new session. I am closing this session. Okay. There is a new link sent to you. They will send a new link to you and please join in. Okay.